Before a single line of SQL code can be written by you, you first need to have a blueprint in place. That blueprint is called a data model, and that's how you go about turning real-world business rules into a structured database. Now, there are three levels of data modeling out there. The first one is the conceptual model, which serves as the big picture, which indicates the key entities and how they relate to each other. There's no technical detail yet, so for example, think about a customer placing orders. The logical model adds more structure, so key elements like attributes, primary keys, and defined relationships. This is still database agnostic though. The physical model, which is also called the relational schema, that is the final blueprint. So it contains information like the actual table names, data types, constraints, and indexes. This is what actually gets built the database. Now there are also entity relationship diagrams, which serves as the core tool for data modeling. Entities are the things that you track. So for example, a customer, a product, or an order, and they're going to be drawn as rectangles within the diagram. Attributes are their properties. So for example, there's name, price, and date, and those are drawn as ovals. Relationships connect those entities together, and those are drawn as diamonds. A customer placing an order, for example, or a product belonging to a category. ERDs live at the logical level of the data modeling, which means that they're precise enough to build from and abstract enough to discuss with non-technical end users. However, relationships aren't just connections, they carry rules. Cardinality defines how many entities are mapped within the relationship, so there can be one-to-one, one-to-many, and many-to-many. For example, a customer can place many orders, and an order can belong to one customer. That's a one-to-many example. Direction tells you how to go about reading that business rule, so from which entity to which entity. Business rules will enforce real-world logic. Every order must have at least one item, for example. A product cannot exist without a category, for another example, and they effectively become constraints within your relational schema for the database. Notation systems like crow's foot encode all this information visually into the entity relationship diagram. Now, there's also relational diagrams, which translate your ERD into actual tables. So each entity will become a table, each attribute becomes a column, and relationships are enforced through a concept called foreign keys. Many-to-many relationships are going to get their own composite table. So for example, we have order items which go about linking orders and products. This final structure serves as your relational schema, the contract that your entire database is going to be built on. So to wrap it all up, there are three levels: conceptual, logical, and physical data modeling. If you model your data correctly, then everything built on top of it for your database will just work effectively. I'm making more videos like these. Be sure, as always, to like, comment, share, and subscribe your thoughts down below. I'll see you in the next video.